EDU30009, Mathematics in the Primary Classroom, Assessment 2, Presentation on a Mathematical Problem. Hello, my name is Lee Swadana and today I'll be presenting a mathematical problem that will consist of two parts and essentially two problems. Understanding the logic of maths is essential as used in every facet of our day-to-day lives. For middle-aged primary children, learning to unravel mathematical word problems can be quite complex. Children need to first understand the problem, work through a variety of strategies that best suits the problem that they are trying to solve. In this presentation, I'll be using Polly's four-stage model of problem solving, which has been taken from Polly in 1973. Polly's model is best used for primary age students as the types of problems are simplistic in sequence and therefore the steps are easier for young children to master. It is also noted that we do not need to use the steps in any particular order or sequence. So now let's look at the problem using Polly's model. Now firstly, there are four parts to this model. Understand the problem, devise or make a plan for solving it, carry out the plan, and lastly, reflect on the process. Now let's look at our problem. Brooke, the detective, looked for a number. She found a two-digit number less than 50. The sum of its two digits was 12. Their difference was 6. What number did Brooke find? When we look at the language, we can pinpoint key elements. Two-digit number, this tells us that we are looking for a number that consists of two digits and that it is less than 50. When we look back at the words sum and difference, we know that sum means to add and difference means to take away. Sometimes it may be beneficial to alter the language used in order for children to best understand the problem that we're trying to explain. So now we devise or make a plan for solving it. So constructing a table can help visualise our steps and look back on the sequence we've used to ascertain the best approach. So by organising the workings out in the table that we have here, children are able to see their own workings and pinpoint missing information. It also provides a visual record of what has been tried so that children can learn not to repeat the same mistake over again. So now we'll look at our first problem and we are going to try the number 48. So again we will look at the key language in the problem that we're trying to solve. So we're looking for a two-digit number and it's less than 50. So that's how we've come to pick 48. And we are looking for the sum of its two digits, which was supposed to come to 12, and the difference is it's supposed to be 6. So now we'll look at our number 48. So we have 40 in the tens column and 8 in the ones column. So looking at the problem, two-digit number that was less than 50, the sum of its two digits was 12. So sum of, we decided, was to add, so 4 plus 8 equals 12. So that's the first part of our equation and we've answered that correctly. The second part is their difference was 6. So the difference means to take away. So 4 take away 8 is 4. Now we need to have a difference of 6. So we know now that this answer is not correct and that is not our number. So now we know that that's not our number. We need to pick another number that's less than 50. So how about we try 39. So it's a number that's less than 50. 30 in the tens column and 9 in the ones. 39, it's less than 50. The sum of, or 3 plus 9, is 12. So that part of our equation is correct. Their difference, so 3 take away 9, 3 take away 9 is 6. So we know now that this is our number, that 39 is our right number. Okay, so now let's look at our second problem, again using Polly's model. Brook found a 2-digit even number. One of the digits was half of the other. The number was greater than 50. What number did Brook find? So again, we start with understanding the problem, making a plan for it, and carrying out our plan. So we are looking for a 2-digit even number. So we already know that the number needs to be even, and it needs to be more than 50. And we also need to know that one of the digits was half of the other. So this means that it can be equally divided into itself. So we now know what we're looking for when we're going on to search or to find our number. Okay, so let's try our first number. We're going to try 54. 50 in the tens column, 4 in the ones. So 54 we know is an even number. It's greater than 50. Can 4 and 5 equally go into each other? So let's divide 4 into itself. So 4 divided into itself, half of itself rather, would be 2, and half of 5 would be 2.5. So we know from here that this is not our answer because these numbers are not equally able to be divided into each other. So we know that's not our number. So let's move on to trying another number. So let's try 84. We know that 84, 80 in our tens column, 4 in our ones. We know that 84 is greater than 50, and we know that that's our first part of the equation is right. Is 4 equally able to be divided into 8? Yes, it is. So 8 divided by 2 is 4. So 4 goes into 8. So we know that this is our number. The 84 is our right number. ACMNA 083, Australian Curriculum Assessment and Reporting Authority, content descriptor has been used to show linking back to the intended learning experience. We can see that looking back, problem solving is vital for learning. From this process, students are able to visualise the steps through looking back at the solution and then make connections through the data collected and strategies used. Furthermore, it has been also found that brainstorming or discussing problem solving ideas is a very effective way to help children become better problem solvers. The Australian Curriculum and Reporting Authority also demonstrates problem solving through the content descriptor ACM SP096. Thank you, that's all.